What we do at Big R Bridge, again, is pretty much accelerated bridge construction every day. We're similar to Wheeler. We specialize in providing modular components, systems and bridge spans that can go together fairly quickly and be in place in a short amount of time. That also gets into a lot of retaining walls, pedestrian crossings, vehicular crossings, a wide variety of different things. One of the projects I'm just going to highlight briefly within this presentation is the Missouri Safe and Sound program, and for us, we got to participate in this with the design build group, and it's really been a great experience and a learning process for us. Their plan is to have 800 bridges off of their bad bridge list by 2014. So when you think about the number of bridges they have to replace every year and the time frame they have to do it, you're really getting outside of what is conventional bridge construction. And it really hits to the heart of what is accelerated bridge. So before we get into kind of talking what is accelerated bridge, I always like highlighting what it's not. It's not for every project. It's not about reducing total number of days. 10, 15 years ago, several DOTs across the country got into, hey, let's try to reduce the amount of time that we're on site for building these projects. It was still a standard conventional design. They just cut the number of days from 190 days to 30 days. The only thing that affected was really the overall cost of what you're going to have to pay for that project. That's not really accelerated bridge construction. And it's not about limiting construction methods. The things that we've learned over the past 10 years, and it really showed in this Missouri Safe and Sound program, was the DOT relaxed their restraints on, okay, we're Missouri and this is what we are approved. We don't care if you use it somewhere else. And it allowed contractors that were bidding on it to say, well, this is what we've learned in Texas, or this is what we've learned in Oregon. And being able to bring those methods in and help improve the overall project. So it's not about limiting the experience or the knowledge that maybe a contractor has that's coming and building your site or doing your project. I thought I'd show some pretty bridges. This is definitely not accelerated, but it's a beautiful looking structure, won several awards, nice spiral type roadway application. Can you imagine it's not something you're going to do overnight or do very quickly. Also, cast in place concrete girders, bridges, those are very economical. It's not something that's going to happen very fast or very quickly. We do a lot of DOT work, composite deck bridges for highway lettings, Wyoming, Colorado, Kansas. But again, we're just providing beams. You're basically building those bridges on site. A lot of the Safe and Sound program is systems, what are called hollow core or box beam bridges. And again, you're just providing beams in that situation. You're not really helping speed up the overall construction process or time or method. But again, you're casting the deck in place on site. You're not really alleviating some of the cost and risk associated with building that. We do a lot of design build projects nationwide. One of our bigger clients that we do a lot of work for is Kiewit and some others, and you get into situations where it's all about speed and how fast you can get something not only to the site, but how can you help them speed up putting this system in. So why accelerated? We've talked about what it's not. Eliminating detours. The most expensive thing on your projects are things you're going to throw away. So if we can eliminate detours, the cost of building detour culverts or just detour right-of-way dirt work movement, if you can eliminate that, that's number one on the list. If the project fits for that, it's really looking good for an accelerated system. Reduce service interruption, and then control liability. And in a longer presentation, I could get into the liability, but you have two fabricators up here, and we try to provide warranties and whatnot for our bridges. But I think through the economic downturn, the biggest thing that we've noticed in that is insurance. Insurance has gotten ridiculous, and we're kind of a small piece of most overall projects. So I can't imagine what it's done to contractors and people that's bidding on your projects and their insurance. So we used to talk about, a buzzword was everyday counts. After this recession we're trying to fight our way out of, it is everyday counts now, because the terms that are out there insurance-wise is just a monster to try to deal with. So a little bit about the Safe and Sound program. Again, they have to get 800 plus bridges off of the system by 2014. This is your legend when you go to the website, so you can see what they've got scheduled, when it's going to let, and when it's going to be complete. And this is an interactive map that you can go to. Everything in green is basically bridge structures that are done, and then the different colors determine it, kind of give an idea of what's coming up next. The bridge that we did is right here on US 61, just adjacent to I-55. A little bit of story about this project. It was within their system, everything's accelerated, the whole entire program. This one got really crazy accelerated, mainly because the DOT had planned an overlay of I-55 on the southbound lane, so that would cut I-55 down to 2 lanes for traffic. To do that, they were, in their schedule, they had that this bridge was already supposed to be replaced. It wasn't yet. So we get the call from the design build group, and once we kind of worked out what our structure was going to be, they said, how fast within 30 days can you design and have this thing on site? Of course, my negotiation skills kick in, so I'm thinking, well, how about 30 and a half? But we ended up having this structure designed, approved, fabricated, and delivered within 29 days. Now that's the entire arch structure that you see internally here. That's also the footing system that's underneath, and also the walls on top. So the only thing that's really field installed or field built is this barrier wall sitting on top of the bridge structure. A little bit about the design build and the dollar amounts there. It's what they did, they reduced the 800, got cut down to 554 for just the design build group, and then the DOT itself is going to be replacing the additional amount to get to the 800, still under the same time frame. This 554, although has to be done by the 31st of 2013. And the contract final award amount was $487 million. I'm interested in this because as this project completes and finishes, I'm interested to see maybe if another state looks at doing this. Because what we've learned through this was the state internally itself, even with MoDOT and the counties, they were like, man, we could have done that. Somebody could have gave us that money, much money, we could have done that same kind of process. The thing that I realized in that short amount of time, there's no room for errors, there's no room for complication of who's getting funding, there's no bickering about where the money's going, it's just got to get done. So that's one thing that I noticed is it really takes out a lot of the issues that you may deal with on a daily basis when you've got that kind of clock ticking against you. Because a lot of times we as steel fabricators, we'll get the call and we're like, hey, we need this really fast. Can you have this steel, or can you have that bridge fabricated here in 3 weeks? Can you have it here in 2 weeks? I need it this month. I needed it yesterday. We could speed that process up till it's just amazing how fast it is. But at the end of the day, you still got to build the bridge. So if we're only addressing how fast we can get beams out there, there's no difference in what you're talking about when you start trying to figure out if it's accelerated. I appreciate some of the presentations here because now you're really getting into, let's look at this substructure. What's the foundation? What's our seals being done with? What are we building out of our walls? And so these are the things we try to look at when somebody addresses us and wants to talk about accelerated. One of the systems that's been around a really long time is what you call soil confinement structures. Now we make ours out of steel. This is basically an abutment here where you'll come in and instead of driving piles, you dig down to a certain point, you build these boxes, you fill them with good soil material, and you set a seal on top of the boxes. That's your abutment. And that's a really fast system. This has improved greatly. There's even precast systems now that are soil confinement type systems where you can come and set the precast boxes, you fill them full of good soil material, set your seal on top. All you're doing is trying to spread out that load over the subgrade that you have. True MSE abutments, and I think that Warren's presentation is going to highlight some experiences that he's had with that. This is probably the biggest call we get now in doing bridges is, you know, can you address the abutment? Is there something you can do with that? So some of these next slides just kind of highlight a little bit of that. And then precast seals, we're getting where we precast a lot of the foundation units. This is an example of a steel stringer bridge. It's setting on a precast seal. It has a precast back wall, and then these are precast deck panels. So it's truly, when it comes to the job site, it's just a kit that you're basically putting together. And then another, just some of the cut sheet, I kind of pulled this out of Chan, but basically some of the methodology we're following as far as utilizing a true MSE button. If we're building a MSE wall or a precast panel MSE wall, why separate this foundation from the bridge by putting piling in there. Why not just make it set on all one system? That way you're not dealing with that settlement issue in the future and trying to figure out what you're going to do with the approach slabs, because they're not setting at the same level that the bridge is anymore. Just some details on the precast seals. This is some great details on foundation systems. U.S. Forest Service has really done a lot of work for buried structures, and these are some of the precast seals details they've come up with. And we've fabricated several of these different types of foundation systems. We produce a modular system like a steel bridge deck. This is basically some shots of that. The idea with that is, one, instead of trying to get a bridge assembled, put it together, and then cast a deck, build your structural deck on it, the deck comes with it. So you're just applying an asphalt wear surface to that steel bridge deck. That's a 7 or 9 gauge structural deck. Precast decks, this is a big thing in Oregon, Washington, Idaho. We compete against probably 3 other steel bridge fabricators in those parts of the country, and they all have a precast deck system. This is just a shot of one of the recent bridges we did. And what we've done there is provided blockouts within the panels. So the bridge comes on a truck, then the panels start coming on a truck, and basically the process with a small forklift or some sort of lifting equipment is they're just placing these panels onto the bridge deck. And we provide these blockouts. And then a little closer up detail is that you can see the shear studs mounted on top of the steel beam. And then this blockout would be filled with grout to give you some interaction there between the steel beam and the deck itself. Just the quick details of that. Some of these panels get quite large. The photos there were not of a very big bridge structure, but you see this is a precast panel that's 32 foot wide. I mean 16 feet wide, so it's making a 32 foot wide roadway. So pretty large deck that you're placing on that steel bridge. This is an example of kind of the hollow core system. This was the MoDOT structure, and this was what was designed before we got involved. And so this is an 80-foot span bridge that they had proposed for that crossing. And then we looked at it and tried to figure out, well, does it need to be an 80-foot span bridge? I know that a lot of times, depends on what your mindset is and how your crews are set up, you're either a bridge building county or you're a box culvert building county or a culvert county. And we try to look at it and see what's a way we can still give you a bridge span, but give you maybe the benefits of a buried culvert or buried structure. And this is our system that we produce for these buried spans. Again, utilizing accelerated foundation methods, that's a precast seal. So that entire foundation system's delivered to the job site. Just different types of shapes. That's a 40-foot span structure. We call that a pretty low-rise arch structure, but in all intents and purposes, that's a bridge span. So the MoDOT Safe and Sound program, they tore out the old bridge. We actually utilized prefabricated footings. So they were accelerated footing system that was installed, and they went in placing the structure on top of those footings. And so these are twin 34-foot span arches. And then I don't have very good shots of the precast panel because it went up pretty fast, but that's an end view again. A little detail from the top. It does have a little concrete collar on it. And then you can see these are precast panels, but usually most panel systems you're not going to buy anymore has no texture to it. So this is what's called an ashlar stone texture. That's pretty common and pretty standard with most panel walls. Just some other DOT work that we've done. This is a 50-foot span structure for New Mexico DOT. We also get some really accelerated calls. This may be familiar for some in the room because this is, I think, in North Dakota, where you have an old structure that's burned out and we need to get something in there really fast. That's an example of that. Animal crossings, we do some really big spans. Those 2 center spans are 60-foot spans. Another North Dakota project. I thought this was interesting because they got this structure in place and got a pretty massive flood the next day. So there it is after they got it finished. How many of y'all seen this photo? We got a few internet junkies. I was wondering if the guy had a heart attack when he woke up or as that process was taking place, but hopefully we didn't scare you with some of the info I've showed you today. And I want you to, be able to take away something. Maybe it's something you haven't ever seen before or don't typically use, but there's a lot of solutions that are out there related to short span steel bridges, just a different type MSE wall system. Precast panel walls work really great. It kind of fits in with kind of the accelerated method you've had in some of the other sessions, but just a really fast head wall, wing wall system that can be put in place pretty quickly.